Hello friends, welcome back my YouTube channel MS Maths. In this video we are going to discuss about the measurable set and Lebesgue's measurable. So what is the definition of the measurable set? So first of all we should have an idea about that what is the outer measure and inner measure. So for example, if you have a set A and outer measure is nothing but the like denoted by in this way, and it is basically the infimum of length of all the open sets. Okay, and similarly the inner measure is basically the supremum of all the length of bounded set, and here A contained in F and here B contained in A. So basically in Lebesgue measure or measurable set, the outer measure and inner measure will be equal. In the similar manner, we can consider or we can say that if E is any real number or E is any set of real number, then we can define measurability in a different or in a different manner. That is basically as E is a set of real number is said to be Lebesgue measure or measurable if for each set A of real number we have. What is the outer measure for in this case? That outer measure is nothing but outer measure of A is equals to outer measure of A intersection E plus outer measure of A intersection E complement, where E is a set of real number. So if this property will satisfy, then we can say that our set E is measurable or Lebesgue measurable. Okay, so there is some remark that the definition of measurability says the measurable sets of those which split every set into two pieces, like this piece and this piece, like the intersection of A and E and the outer measure of intersection of A and E and outer measure of intersection of A and E complement. So the outer measure of A will split into two parts in the form of the intersection of E and complement of E. Okay, if a set E is measurable, then its complement is also measurable. Like in this case, you will take an intersection with A of the E complement, then E complement should be measurable in this way. Then how will you prove it? Then we can easily prove it. Given, what is the given? So given is basically that E is a measurable set, and we will show that E is a measurable set, and we will show that E complement will be the measurable in this way. Okay, so basically we'll have then the outer measure of A is equals to the outer measure of A intersection E plus outer measure of A intersection E complement. This is by the definition of measurability. Okay, then if it is measurable, then this this condition will satisfy by using the definition of Lebesgue measure. Then outer measure of A is equals to the outer measure of A intersection E complement plus, we will take the complement in the right hand side, then it will be outer measure of A intersection E complement of complement. So it will be M star or outer measure of A intersection E complement plus outer measure of A intersection E complement. It means if we replace E by E complement, then it is satisfy here, that same condition will satisfy, so that E complement is measurable because of that E complement of complement is nothing but E. So in this way we can prove this, and by using this we can satisfy, or using this condition we can prove this property. Now next we have for any set, this is the third property that we have. For any set A and E of real number, we have A is equals to A intersection E union A intersection E complement. So by using the same definition, or if it is equation number 1, then taking outer measure in equation number 1, then we'll get the outer measure of A is basically if we put the outer measure, then what is the outer measure? It is the infimum of length of all the open sets. Then it is always, there is a condition, it is always less than, obviously it is union, then it will add, and this, the length of this particular, or the outer measure of this particular set A is obviously less than the outer measure of A intersection E plus outer measure of A intersection E complement. And this is why this is the condition by the countable subadditivity that we have already discussed in our previous lecture. Thus, the necessary and sufficient condition for a set E to be measurable is that the outer measure of A is equals to, or basically, yeah, is equals to outer measure of A is equals to the outer measure of A intersection E, okay, then outer measure of A intersection E complement. So by using this condition we can have this value, and to prove it, if A is measurable and A is any set of real number, then to prove this condition, if we get this condition, it means this condition will automatically satisfy. Okay, so this is all about the measurable set and Lebesgue set. So this is the condition, this is the basic definition which we will use in our next further all the theorems. So thanks for watching my video, keep watching MX Maths, and for these types of video you can follow my channel. Please subscribe the channel, like the video and share. Thank you, bye bye.